ID, and the port ID include two parts. The first 8 bits is the port priority, okay, port priority, and after that the next part is the port number, okay. And you know that the port priority can have for example use one value between the 0 to 225, okay, and the default value is the 128. Because of that, we can say that, for example, the gigabit 01 cost or port priority, okay, or PID is 128.1, for example. And also the gigabit 02's port ID is 128.2, and so on, okay. Here, you know that in this scenario, we have two switch 1 and switch 2. Switch 1 has the lower MAC address than the switch 2 because of that the switch 1 is selected as the root bridge. You know that in switch 2 we need to find the root port, and we should use the lowest cost interface, okay, for the root port. The cost of two interface or two link are same to root bridge. Both of them are using the 1 gigabit per second interface. Because of that, the cost of port 2 and port 1 is 4. We should use the tiebreakers. The first tiebreaker says that the lower sender bridge ID is the better port. Look at here, the port with lower sender bridge ID. For example, the port 1 connected to the switch 1 and the port 2 of switch 2 connected to switch 1 again. Because of that, we can say both of these port 1 and port 2 are connecting to the same sender bridge ID. Because of that, it is not same switch or sender bridge ID. This is not for example, useful for selecting the root ports. The second rule in the tiebreakers says that the port connected to the port to the sender port with lower port ID is the better port. For example, you know that here the port 1 connected to the port 2, and the port 2 of the switch 1 by default has the 128.2 port ID, and the port 2 of switch 2 connected to the port 1 of switch 1, and the port 1 has 128.1 port ID. Because of that, the point 2 connected to best port or the lower PID, and because of that, this is the root port. This is the normal behavior, but we can change this normal behavior. For example, if you want, you can change the port priority of the switch 1 port 1 or switch 1 port 2. For example, I'm going to use the port 1 of the switch 2 as the root port. I can configure the priority of the port 1 of the switch in other side to the 64 point, for example, to, you know that I changed the 128 to 64, means we are configuring the port priority, not the port number. How? With the easy command. Let me write here for configuring the priority. Again, we need to go to the interface, switch config if. Here you can use a spanning tree. Then again, you have the option to configuring the priority for each instance of STP independently, spanning tree VLAN ID, then port priority. So easy, okay? And here you can use a value between 0 to 255. Don't forget here, we should use the values in increment of, for example, 16 in some iOS and maybe in another iOS 64. Okay, let me to show you here in packet tracer. First, let me to try this scenario, and I'm going to add two switch. This is the switch, for example, 1. This is the switch 2. Let me to remove the previous scenario. We don't need this scenario. Okay, and after that we can for example use the switch 5 and switch 6. Okay, the switch 5 BID is 0001. This is the MAC of the switch 5, and the switch 6 has the MAC of 0002. Because of that, and now we expect to selecting the switch 5 as the root bridge. Port gigabit 01 of the switch 5 now connected to the gigabit 02, and gigabit 02 of the switch 1 now connected to the gigabit 01 of the switch 6. Okay, and let me to change the names from the switch 5 to switch 1 and from the switch 6 to this for example switch 2. After some second we can verify the result. Look at here. Yes, port gigabit 01 and gigabit 02 of the switch 1 now as you can see, are green, and the port 1 of the switch 2 is amber and the port 2 is green. Let me to show you the switch 2 status. This is the switch 2 CLI. Here I'm going to configure the host name to switch 2. Okay, hostname switch 2, then show spanning tree can show us that the gigabit 01 is alternate. Why? Because the other side in the other side in the switch 1, this port connected to the port 2, and after that the gigabit 02 is the root port. You know that in the other side we are using the we are connecting this port, the gigabit 02, to the gigabit 01. Okay, it's okay. Let me to configure the gigabit 01 of the other side in the switch 1 with the for example another priority. Look at here, conf host name switch 1. I'm going to change the gigabit 01 in the switch 2 to the root port with reducing the priority of gigabit 02 in the switch 1. Okay, I'm going to configure interface gigabit 02. Okay, interface gigabit 02, and then spanning tree. Okay, priority or port priority. Okay, spanning tree. For example, VLAN ID, it's not necessary, port priority, and then we can configure the port priority in increment of 16. For example, I'm going to use 64. Okay, 64 is less than the 128, and then show spanning tree interface gigabit 02 detail. Look at here. Here we can see the port priority is as 64. This means that here this is working. Also in the show spanning tree, as you can see, this is changed. It's okay. Packet tracer support it, and after that in the switch 2 we can check the new status, show spanning tree. Yes, it's working. Look at here, gigabit 01 now has the root port, but in the previous part, as you can in the previous section, we saw that the gigabit 01 was the role had the role of the alternate, but now it is the new root port. Let me to show you again, show spanning tree. Yes, gigabit 01 that connected to the gigabit 02 of the other side now is the new root port. After that, gigabit 02 is the alternate. Look at here, let me to review. Here in our scenario, we can see that the gigabit 01 that connected to gigabit 02, and this is the root port, because the gigabit 02 in the other side has the lower for example priority. Look at here, gigabit 02 has the lower port priority. It's so easy. Also, let me to show you the same scenario in other emulator. It's useful to for verifying in the EVE-NG also. As you can see in this scenario, we have switch 1 connected to the switch 2, the port 1 of switch 1 connected to the port 2 of switch 2, and the port 2 of switch 1 connected to the port 1 of the switch 2. Let me to show you the default status. Show a spanning tree in switch 1. Look at here, we have two ports. Both of these two ports are designated, and because this bridge is the root, so easy. In switch 2, show a spanning tree. Okay, it can show us that the gigabit 01 is the alternate port, because the gigabit 01 connected to gigabit 02 with the higher port ID, and the gigabit 02 is the root port, because the gigabit 02 connected to gigabit 01 with the lower port ID. Let me to change the priority of the gigabit 02 of the switch 1. Interface gigabit 02, a spanning tree, for example, port priority. Okay, then we can use any value between the 0 to 240 or 255, because the next step is beyond the 255. Here you can see the 240. Okay, let me to use 16 or any other value. Okay, less than this 128. Now show a spanning tree in the switch 1. This is the switch 1, can show us that the port ID of this interface gigabit 02 was changed to the 16.3. It's okay, okay, because we configured the port priority. In the next side, okay, we will see the effect of this configuration. Look at here, now the gigabit 01 that had their alternate role now has the root role, and gigabit 02 that had root role before now has the alternate role. After some second, this will change to the state will change to the forward and for the gigabit 01 and block for the gigabit 02. So easy and also so understanding. Also, let me to say that